Bismillahirrahmanirrahim. My dear students, Assalamu alaikum. You are watching Math with Yasir Arfat. Today we are going to discuss three important questions, most important questions of the derivative of exercise 4.3. These are the most expected question for forthcoming exam. So here, first question here, that is the question number 7, which is the most important question of the exercise 4.3. We have to find out the derivative here, dy upon dx of this equation. So here, differentiate with respect to x. So here, this is d over dx x square plus y square, and the radical means 1 upon 2. We have to apply the operator here, dy upon dx of ln x square minus y square. So here this is 1 upon 2, this is the value of the radical. Now here we have to apply the power rule on the left hand side. So first we have to find out the derivative of the power and then the function. So this is the coefficient 1. So coefficient multiply with the power, it is 1 over 2 x square plus y square. Then we have to decreases 1 from the power. This is the power rule and we have to find out the derivative of the power. Coefficient will multiply with the power and decreases 1 from the power. So now we have to find out the derivative of the function, that is x square plus y square. This is called power rule. First we have to find out the derivative of the power and then the derivative of the function, that is x square plus y square. Similarly here, the derivative of ln, we have a formula of derivative ln x, it is equals to 1 over x. This is the formula of ln x here. So the derivative of ln x, x means here x square minus y square. So the derivative of ln is 1 over x square minus y square according to this formula. Then we have to find out the derivative of x square minus y square. This is the derivative of the function, and then we have to find out the derivative of x square minus y square here. Now come to the left hand side again. 1 upon 2 x square plus y square, half minus 1 means 1 upon 2, and now derivative of x square, it is equals to 2x. Derivative of x square, it is equals to 2x, and now come to the y square. So derivative of y square, so here on y square we have to apply the power rule, that is 2y, 2 minus 1, and then the derivative of y will be equals to dy upon dx. Because the derivative of x is 1, so therefore there is no need to find out the derivative of x here. Now focus here, this is x square, so the derivative of x square, it is 2x. Now here focus y square, so the derivative of y square will be 2y, and then the derivative of y will be equals to dy upon dx. So here this is 1 over x square minus y square. Again here the derivative of x square, it is 2x, derivative of y square, it is 2y, and the derivative of y, that will be dy upon dx. So here derivative of x square is 2x, minus remains same. The derivative of y square will be 2y, and the derivative of y will be equals to dy upon dx. Now this is 2 over x square plus y square. When we have to shift this minus 1 upon 2 in the denominator, so this will be minus 1 upon 2 will change into plus 1 upon 2, and 1 upon 2 means the radical here. So just take out 2 common here. So this is x plus y dy over dx. and here just we have to multiply with 2x, so that will be 2x over x square minus y square. 1 multiplied by 2x will be equal to 2x divided by the same, minus 1 upon x square minus y square multiplied by this factor, so this will be 2y over x square minus y square dy over dx. Simply this is the ordinary multiplication here. 1 over x square minus y square will multiply by 2x, that will be 2x over x square minus y square. 1 over x square minus y square will multiply minus 2y, so it will be equals to 2y over x square minus y square into dy upon dx. So this 2 will cancel out this 2. Again we have to multiply this one, same as we have to multiply here on the right hand side. So 1 over radical x square plus y square multiplied by x, so it will be x over x square plus y square. Similarly 1 over radical x square plus y square multiplied by y, so this will be equals to radical x square plus y square multiplied by y, and dy upon dx remains same. So here in this equation, this is x square minus y square 2y over x square minus y square dy upon dx. So this is, here we have to find out dy upon dx. So this dy upon dx we have to shift out to the left hand side, and this one to the right hand side, because we have to separate dy over dx, our required dy upon dx. So similarly this is y over radical x square plus y square dy upon dx. This is minus, we have to shift here to the left hand side, so it will be plus x square minus y square dy upon dx. We have to shift this one to the left hand side. Now here this is 2x over x square minus y square, and we have to shift out this one left hand side to the right hand side, so this is plus, it change its sign, positive into the negative. So this is x square plus y square here. Take out dy upon dx common here, so this is y over in the radical x square plus y square 2y over x square minus y square. Just we have to take out the LCM here, common first, dy upon dx, and the LCM on the right hand side. This is the simple LCM here between two fractions. So this, the product we have to write down here. So this denominator will multiply with this numerator, and this denominator will multiply with this numerator. So this is 2x times radical x square plus y square, and this is this one, x times x square minus y square. Same as we have to take out the LCM here, it is x square minus y square into radical x square plus y square. So this is, this multiplied by this, it is x square minus y square plus 2y radical x square plus y square. Just take out the simple LCM between two fractions on the left hand side here, and this is remains same, x square plus y square minus x square minus y square and whole divided by x square minus y square and radical x square plus y square. Now dear students, the whole denominator this will cancel out to this one, and this is in the product form when we have to shift to the right hand side. So then we have the value of dy upon dx here, that is take out x common from the numerator, and this is x square y square minus x square y square whole divided by, here we can take out y common as well. So this is x square minus y square plus 2 radical x square plus y square. This is the answer of this question. Most important question of exercise 4.3, question number 7. Now come to the next question, that is question number 8 of the same exercise. Most important question again, and we have to find out dy upon dx here. Dy over dx we have to find out here. So this is differentiate with respect to x. So we have to apply the operator on both sides. D over dx e of x ln y, it is equals to d over dx sine inverse y. So here there are two functions, one is e of x and the another one is ln y. So here we have to apply the product rule here. When two functions are in product form, so that is u as it is derivative of v plus v as it is derivative of u. This is the product rule. When two functions are in product form, then we have to apply this formula here. So this is u means e of x and the ln y means v. So here we have to apply the formula, this formula, that is u as it is derivative of v plus v as it is derivative of u. Here we have to apply the product rule, and this is derivative of sine inverse y. Its formula is 1 over 1 minus x square. Here the value of x is y. So this is the derivative of, if we have a formula sine inverse, it is equals to 1 minus x square. X means angle of the function here. So here what is x? Y. So this is the derivative of sine inverse y. So now we have to find out the derivative of its angle, because its angle is y and the derivative of y is dy upon dx. So that is why we have to find out the derivative first. We have to find out the derivative of the trigonometric function, that is sine inverse y. Sine inverse y, its derivative is 1 over 1 minus y square. And then we have to find out the derivative of its angle here, that is y. It will be dy upon dx. Now here this is ln y, derivative of ln x, it is equals to 1 over x. The formula here. So this is ln y. So the derivative of ln y will be equals to 1 over x. So here what is x? Y. That will be 1 over y. And then we have to find out the derivative of y. Here, focus again dear students. This is ln y. So the derivative of ln y will be equals to 1 over y. And then we have to find out the derivative of y. That will be equals to dy upon dx. And this is ln y. And this is e of x. The derivative of e of x remains same. Derivative of e of x, we have the formula here, that is remain same. So these four formulas which we have to apply in this question here. We have to find out dy upon dx, and this is e of x over y dy over dx, and this is ln y into e of x. It is equals to 1 over y square dy upon dx. So we have to shift this dy upon dx to the right hand side because we have to find out the value of dy upon dx. So this is ln y into e of x, and it is equals to 1 minus y square dy upon dx minus e of x divided by y dy over dx. So just take out the LCM here, ln e of x. Just take out first common and then LCM. So this is 1 minus y square minus e of x divided by y, and this is dy upon dx. Take out dy upon dx common here. Now take out the LCM here. So LCM will be the product of this denominator, that is y into 1 minus y square, and this y multiply by this 1, and this denominator will multiply with this numerator. So this is y minus e of x into 1 minus y square. This is the LCM of these two fractions here. We have to find out the value of dy upon dx here. So then we have to shift this one to the left hand side here. So that will be y into 1 minus y square over y e of x into 1 minus y square, and this is ln y of ex remains same, dy over dx. So this is the result of this equation, that is dy upon dx e of x ln y into y into radical sign 1 minus y square divided by y minus e of x into 1 minus y square. This is in product form, so we can write down in numerator like this. This is the answer of another most important or the most expected question of the exercise 4.3. Okay students, now come to the last important question, most important or most expected question of exercise 4.3. This is x power y into y power x. When we have a power in the form of the function or the variable, those type of equations are called exponential type equation. So here first we have to rearrange this equation. So this is x power y, y power x. One of them we have to shift to the right hand side. So this is x power y and this is x power minus x. Now in exponential equations, when we have to find out the derivative, so before finding its derivative, first we have to take out ln on both sides. So here taking ln on both sides. Why? Again, this equation is exponential type equation. What is the exponential equation? When we have a power in the form of the variable or the function, so those type of equations are called exponential type equation. And when we have to find out the derivative of exponential type equation, So before find out the derivative, we have to take out the ln here on both sides. So this is ln xy and this is ln y minus x. So we have a rule for ln function. If we have ln a power b, then the power become the coefficient of ln function, log natural. So here this y become the coefficient of ln, and this is minus is the power become the coefficient of ln according to this rule. Now here again we have to apply the u into v formula on the left hand side as well as on the right hand side, the product rule which we have discussed in the first question. So this is the product rule again, u as it is, derivative of v plus v as it is, derivative of u. Two functions are in product form. Now we have to find out the derivative. So differentiate with respect to x. So apply the operator first. So this is d over dx minus, we can write down here, and if you have to write down this minus with negative sign with x, there is no problem at all, we can do. Now here we have to apply the u into v formula here. So u as it is, derivative of v plus v as it is, derivative of u. U is y and v is ln x, and we have to apply this product rule on the left hand side as well as on the right hand side. This negative sign remains same. So here u is x and the v is ln y. So u as it is, derivative of y, v as it is, derivative of u. So here derivative of ln x, it is 1 upon x. So this is ln x. The derivative of y will be equals to dy upon dx. Derivative of y is dy over dx. If we have to find out the derivative of x, it will be equals to 1. So there is no need to find out the derivative of x here. So here x again ln y. The derivative of ln y is 1 over y, and the derivative of y, it will be dy upon dx. Similarly, ln y remains same. The derivative of x will be equals to 1. So this is the minus, we have to multiply this sign. So this is y over x ln x dy over dx, open the bracket with the negative sign, minus xy dy upon dx minus ln y. The same situation here also, we have to shift this one to the right hand side and dy upon dx to the left hand side, because we have to separate dy upon dx. We have to find out the value of dy upon dx here. So this is dy upon dx plus x upon y dy over dx, and here this is minus ln y, this is minus y over x. Just take out dy upon dx common here. So this is x over y dy upon dx. Just take out the negative sign common here, y over x, and now we have to find out the value of dy upon dx. It's up to you, you can take out the LCM as well. This is ln x, x upon y. This is the derivative of this function, that was the exponential type equation. Dear students, we have discussed three very important question, most expected question of exercise 4.3. Thank you so much, dear students. If you like this video, please share it and subscribe my channel Math with Yasir Arfat. Allah Hafiz.